Piping Layout and Support System Design, API 686 plus ASME B31.3. Intro. Welcome back to 3D Decode. In this video, we'll talk about one of the most critical aspects of compressor package design, piping layout and support systems. Poor layout or weak support can lead to vibration, nozzle load failures, and costly downtime. Let's dive in. Governing standards. In piping design, everything starts with the standards. ASME B31.3, process piping, covering design, wall thickness, flexibility, and testing. API 686, recommended practice for machinery installation and piping design. API 617 and API 610 define nozzle load limits for compressors and pumps. MSS SP 5869, standards for pipe supports. Piping layout principles. Good piping layout means safe, reliable operation. Here are the key principles. Nozzle loads. Keep loads within API allowable limits using flexible routing, elbows, and offsets. Accessibility. Valves, drains, and vents must be easy to operate. Safety. Hot lines must be routed away from operator walkways. Relief valves should discharge to a safe location. Drainage. Slopes must allow liquids to drain to the low point. Vibration control. Avoid long, unsupported spans that can cause resonance. Types of pipe supports. Now let's look at the types of supports used in compressor packages. Rigid supports. Rest, a shoe-on beam, basic vertical support. Guide, allows axial movement, restricts lateral. Anchor, fixes the pipe in all directions. Spring supports, used when large vertical movement is expected, for example in hot lines. Can be constant load or variable load. Hangers, for overhead piping. Snubbers and dampers, to handle dynamic loads such as earthquakes, surges, or pulsations. Typical compressor package piping. In a compressor skid, you'll usually find suction piping, large diameter, short and straight with a strainer. Discharge piping, routed upwards or sideways, includes check valve and block valve. Seal gas lines, small bore, neatly routed to the seal panel. Lube oil lines, tubing or piping to bearings and seals. Drains and vents, located at low and high points. API 686 guidance, critical points. API 686 gives very practical guidance. The first support should be close to the nozzle, but not rigidly fixing it. Allow for thermal expansion with guides and expansion loops. For hot piping, use expansion joints or flexible loops. For cold piping, ensure insulation clearance at supports. Mini quiz. Time for a quick quiz. 1. Which standard governs process piping design? 2. What is the function of a guide support? 3. Why must nozzle loads be kept within API limits? 4. Which type of support is used for piping with large vertical movement? Practical task. Here's an exercise for you. Sketch a simple piping layout with suction and discharge lines. Suction strainer, compressor suction nozzle, discharge line with check valve and block valve, plant piping. Show supports. 1 rest near nozzle, 1 guide, 1 anchor. This sketching practice is a great way to build visualization skills, and it's often asked in interviews. Interview Q&A 8. Here are some common interview-style questions. Q. Why is the first support location critical near compressor nozzles? A. To minimize nozzle load transfer, prevent vibration, and maintain alignment. Q. What's the difference between an anchor and a guide support? An anchor fixes the pipe in all directions, while a guide allows axial movement but restrains lateral motion. Q. How is thermal expansion managed in piping? A. With expansion loops, flexible routing, spring supports, or expansion joints. Q. Why is suction piping designed short and straight? To minimize pressure drop and avoid flow disturbances at the compressor inlet. What happens if nozzle load limits are exceeded? A. Misalignment, vibration, seal failures, and even casing cracks. And that's it for today's session on piping layout and support system design as per API 686 and ASME B31.3. If you found this video helpful, don't forget to like, share, and subscribe to 3D Code for more engineering knowledge. See you in the next video.